This video is about the vertebral column primarily. It'll include the ribs, but I also want to show you a bone right up here. It's kind of hard to see. I'll move it's not attached to any other bone. It's the only bone in the body that has no articulation with another bone, and it's in the neck. Neck muscles are connected to it. It's right above the larynx. Okay, I can't find the model of the larynx to show you, but you can see it here on the skeleton. Wish I could show it to you a little, but it's in the neck for the muscle bones. It's called the hyoid bone, Hyoid. And the thing about the hyoid bone is that it has no articulation to any other bone. So when they have an articulated skeleton like this, they have to put, you probably can't see it, but they have to wire it to one of the cervical vertebrae so that it'll stay in place. Just wanted you to know the hyoid bone. It is part of the axial skeleton there, and so therefore we want to make sure that we don't neglect that poor little old hyoid bone. Okay, so now we're going to look at a little model right here for a minute. Okay, and this model right here is a model of some vertebrae right before the sacrum. So these vertebrae would be called what? Lumbar vertebrae. We're going to look at them separately. Okay, and then this is the sacrum, fused bones. This model is neat because you see why you have the arrangement you do with the vertebrae. The vertebrae protect, see this big yellow structure going through here? That is the spinal cord. The spinal cord. And it goes through the vertebral foramen. Foramen's a hole. Then you see these yellow things sticking out on the side. Those are spinal nerves. We're going to study the spinal cord and the spinal nerves when we get into the nervous system. Also, another thing you can see on here that I think you need to know is these are your discs. See these gray things? Those are vertebral discs. They're between two of the vertebrae. See that? Okay. So you can see the spinal cord going through the vertebral foramen. We'll look at one vertebrate in a minute so we can see what that is. And then we'll also then see that cartilaginous disc, spinal nerves, and one more thing I want to show you while we got this. See right here where the spinal nerve is coming through? It comes through what's called an intervertebral foramen. Foramen means hole, and intervertebral means between the vertebrae. There's not a hole in either one of those vertebrae, but the notch on this superior vertebrae and the notch on this inferior vertebrae make a foramen, make an opening for the spinal nerves to go through. So I hope you can see the number of things that are neat about this little model. Okay. A student of mine years ago gave me a whole bunch of these because he was a pharmaceutical rep with I know it's inverted, with the Voltaren Geigy company. So anyhow, this was advertising some diclofenac sodium. Norman Schwartz gave me about half a dozen of all different kinds of little anatomical models. So now let's look at a typical vertebrae, okay? And that would be this vertebrae. I'm using this because it has colors on it, so you can see the different features. Okay, and the first thing that you should notice that all of the vertebrae except the atlas, we'll be looking at the atlas in a minute, all of them have this big structure right here, which is called the body of the vertebrae. And then all of them except the atlas have that. When we look at the atlas, you'll see that it does not. And there's a reason, and we'll talk about that when we get there. Okay. Then, oh, you can see my eyeball right through the vertebral foramen. That's where the spinal cord passes through. Okay. And now you'll see three things that stick out on this vertebrae. Okay, there's one on this side and one on this side, and then there's a stick out up here. Okay, whenever anything sticks out on a bone, they call it a process. The ones on the side are called transverse processes, and the one on the top is called a spinous process. Okay. Now, another thing you'll notice is there's an arch. It's called the vertebral arch that is formed around the foramen. You know what an arch is. Now, there's a top part of the arch which is above the transverse process, and that's called the lamina, Lamina, and then the bottom part of the arch is called the pedicle, Pedicle. So the arch is the whole thing on the side. The top part of the arch is the lamina, okay, and the bottom part of the arch is the pedicle. Okay. Okay, so now there are also some articulating facets, okay, and they're indicated by these blue things. The ones on the top, there's four of them altogether, are called the superior articular facets, okay, and therefore articulating with the vertebrae. These are the superior articulating facets, so they articulate or touch the facets of the vertebrae above them. And then down here we have the inferior articulating facets. See, and these are the inferior because they're on the below the vertebrae, on the inferior side, and they articulate with the vertebrae below them. So you have four articulating surfaces, two superior articulating facets, facets, and then on the bottom you have two inferior articulating processes. So then the last thing I want to show you I'll show you a couple more things. My wife always says I'm Columbo because I say one more thing. See my eyeball through the vertebral foramen. This is the cartilaginous disc. There are discs, the vertebral discs made out of cartilage in between adjacent vertebrae. Okay, and then you can see the spinal nerves coming out on the side, and remember they go through that intervertebral foramen formed by this notch and the notch on the bottom. If I can see, I get all mixed up because I'm spatially impaired. The spatially impaired anatomist. The spatially impaired anatomist is analogous to the tone-deaf singer, the tone-deaf vocalist. you're working with a spatially impaired anatomist. Okay, well, you can see the vertebral disc. This is the body of the vertebrae. This is the transverse process sticking out on the side, and then this is the spinous process. Okay, so that's a typical vertebrae, the structure of it. And you can